Hey class, okay, we are ready to make the ears hear the barks in our good dog class in Ruby. And this is what we were talking about before, something that's very important for getting object-oriented programming to really make sense for our application. And that is we want individual objects within the code to be listening to messages and other things coming from other objects and then responding in kind of a natural way. And we talked about this little example of where I have one object, the Alexa object, she says speak, she has a behavior, she sends the message speak, and then these other objects, um, have their own behavior based on that message. Excuse me. Then we expanded that and we said, well, Um, let's make it more realistic. Let's make it like a room full of puppies. A room when puppies hear each other barking, they will sometimes bark in return. So if Alexa says speak, they'll all speak once, but then the other sometimes they're like, oh, I heard barking, I need to keep barking, and they'll keep barking and keep barking. So that's the behavior that we're looking for in this. I just want to point out that Megan sent me this really cool thing where she had simulated this on Hopscotch. So you reload it. And then I think we click, oh, it's just working. And they listen to each other and they start talking and responding to messages. Sometimes they'll talk, sometimes they won't. So it's kind of a, who is talking, and the barkiness stuff is encoded in here. So great job, Megan, on that, and especially applying it to a whole new program by yourself. Very good job. Hopscotch looks excellent, by the way. I'm hoping to get my husband to put it on his phone so I can play with it. So we're going to go backwards a bit. So just for this first part, last homework you took Good Dog, and you took Good Dog, and you were able to put an ear object inside and a bark object inside of Good Dog. So last homework was objects can contain variables, they can contain methods or functions, things that the object can do, and they can also contain objects. And we talked about how a robot object might contain an arm object, the arm object might contain an elbow object, and so on. So helps us really make that object-oriented language work for us. Procedural stuff that isn't object-oriented, that's going step 1, step 2, step 3 in a very orderly manner, that has a lot of great applications. But when we move over to object-oriented stuff, we want to make sure we use it to the maximum. So this is how we do that. For step 1 in this homework, we're going to go backwards a bit, and we're just going to have 2 objects, and they're not going to be inside of anything else. They're just going to be objects on their own. We're going to have a bark object, and we're going to have an ear object. By the time we get to the end of this homework, you will have put these back in Good Dog, and you'll have a dog that can listen and bark. Okay, we're going to get a head start with this. A lot of your homework has been done by the people who made Ruby, and we're going to get a head start with this with a keyword called require. In Ruby, the word require says load in a library of functions so that we can use them without having to code them. Many of these come with Ruby. You can also write your own sets of functions. There's another thing called a module that I'm going to give you like a probably the last lecture we talk about. I'm going to talk to you about modules and things like that. But you can bring in your own functions, or you can require Ruby's functions. Require usually goes at the beginning of the file. I don't think Ruby cares particularly. C does care, but it's good practice to put it at the beginning of the file so that you remember what you're doing. You can require more than one set of functions. So if you need more than just what's in the, we're going to use the require observer. And it's kind of interesting because even though it's just called require observer, it also gives us the stuff for making the bark observable. So we're going to require the observer library, and it has those single quotes. Okay. Oh, so I said in C, you do the same thing, and we use the keyword include with a little hash in front of it. It definitely goes at the beginning of the file. Files that have library functions in them end with an H, a .h. Two of the big ones that you use a lot in C are std IO, which means standard IO. And if you don't put that at the beginning of your C program, things like print that you expect to work they're just not going to work. That's in standard IO. It's a very standard thing to include at the beginning. Probably always want to include standard IO. Can't think of a case where you wouldn't. Some things that people don't know is there's things like include math.h, and it has a lot of the stuff in math.h that you want to do. So you'll often at the header, well, this is also called a header, but it's a .h file. At the beginning, you'll also often see a long string of includes that include all the libraries that you're going to put in, or header files. In general, in any programming language, if you're trying to do something that's pretty basic and it doesn't seem to be available, go out, check on the web, check on other resources for how to include the standard libraries. Remember, a good programmer is a lazy programmer. Don't spend your whole week rewriting a function when there's a really good one, or maybe a set of good ones that are slightly, one's a little bit more this, one's a little bit more that. At least look at the standard library functions to make sure they don't meet your needs before you program a new function. Okay, in this case, we're going to type this keyword require observer, and we're going to do it right before our class Bark. And inside Bark, we're going to say include observable. It's kind of weird that it's the same word as C, but what that means is inside every Bark object, I'm going to have access to all the functions that make Bark an observable object. So Bark will get a whole bunch of functions added to it that we're not going to see in our class definition. They're in that special set of library things. So we're going to include observable, we're going to change, so that makes the class of Bark observable. Then we kind of just go on with our other definitions. Inside our class ears, we're going to add a special function called update, and that's going to have our behavior that happens when we update it. Without that, make something update others, make the others do something when they're updated. That's the magic of the whole thing. So once we include observable in Bark, we'll be able to get this function called add observer. We're going to have to add our ear objects before they can observe the bark or before they can hear it, in our thing. When you have an observer, it must have a changed thing in it. We'll see that in a second when I look at when we show you the code. And it must have a notify observers. And of course, the ears need an update function so that when they are updated, it'll be more clear in a second. When they're updated, they do something. Okay, so let's look at the code. All right, let me try to make this bigger because I was looking at some of the other ones and it's hard for you guys to see it. Okay, so here we are, line 5, we require observer, class Bark, include observable. All right, the fact that I have included observable lets me use this right here and this without having defined what they mean. They are defined inside this whole set of functions. So what this is going to do, it's going to initialize my Bark as normal, and then whenever it barks, he's going to output his bark, and then he's going to change his status to change, and he's changed, and he's going to notify observers. And we put this self in. Self just says, notify the observers that I myself have changed. I don't know when you wouldn't use self there. It doesn't seem very good practice to me to notify observers. I think everybody should be in charge of their own notification, but you might. Inside the class of ears, when we are updated, and I got to define that this was change sounds, when we're updated, we're going to put out the thing I hear barking. Okay, in the next video, I'm going to finish up with this, and we'll start on, we'll probably get to the other section of homework. All right, bye. I figured out how to add the two videos together, so this is all just one video. So just a second, I'll be right back to finish up that first part. Thanks. All right, in our last video, had just finished, we just finished doing our ears, and we saw that when they're updated, when this notifies the observers, the ears are gonna, well, the ears are gonna talk and they're gonna say, I hear barking. Okay. So those are all of our definitions. Now to tell the code to do stuff. So first we do ears equal ears.new. Create a new set of ears, and it doesn't require input, so this is fine. We now have something called ears. It's an object. Then we create a new bark. Bark equals bark.new, and it requires a string, and that string will be what it takes in when it initializes and what it puts out when it's done. Okay. Then, just as I mentioned in the last thing, we have to add an observer. So we go to bark, and this dot, remember the dot means that this belongs to that. So add observer is a function inside our bark object, and we got that when we included observable in that bark object. And we add this object. They're going to add an observer. Now that means whenever I notify observers, I'm going to notify everybody who's gone through this. And then I say bark.bark now. Okay, let's see it in action. Arf, I hear barking. Great, so it worked. Our ears worked. Okay, I will be right back with our final video on this. Thanks. Bye.